Okay, last video. I know these have been on the long side, so nice job sticking with it. Example 3, how can you determine the number of solutions of a quadratic equation without solving it? So this question is different. They're not asking us to find what the solutions actually are, but just how many solutions you have. A quadratic equation can have two solutions. We found a bunch of those already. It's possible to have one solution or to have no solutions, no real solutions. So we use this thing called the discriminant to help us determine how many solutions a quadratic equation will have. So our discriminant, so how can you do this? We're going to find the discriminant. So in our vocab, we said the discriminant was b squared minus 4ac. I did point out that it gets pulled right out of the quadratic formula. So you know you have the square root of, this is the number that we have been square rooting. So if that b squared minus 4ac, if that value is greater than 0, there are two real solutions. If you calculate b squared minus 4ac and it equals 0, like on the dot it's equal to a 0, there is one real solution. And then the last thing that might happen when you do b squared minus 4ac, your number could be negative. So if that number is less than 0, there are no real solutions. All right, so what's nice about the discriminant, it's less math than the quadratic formula, but we do have to understand what our answer represents. So find the number of solutions for the following. Part A, x squared minus 4x plus 3 equals 0. Just like the quadratic formula, to do the discriminant, you need your equation set equal to 0. You can identify your a, b, and c. So here's a, b, c. And then we just calculate out b squared minus 4ac. So b is negative 4. Put parentheses around everything you plug in. So b squared minus 4 times our a is 1 and our c is 3. We grab our calculators, type that in very carefully, we get a positive 4. So if your b squared minus 4ac is greater than 0, there are two real solutions. So find the number of solutions. This equation will have two real solutions. I don't know what they are. 4 is not a solution, but because the discriminant is positive, that tells me there are two solutions. This parabola crosses the x-axis twice. All right, next example, we have, in part B, we have standard form already. So here's your A, B, and C. We calculate out our discriminant, so b squared, 4 squared minus 4 times our A is a negative 1, C is a negative 4. When we calculate that, we get 0. So up here, if b squared minus 4ac equals 0, there is one real solution. Here, maybe we'll just provide a little visual. When there's two real solutions, your graph could look something like that. When there's one real solution, and the solutions, by the way, are right here and right here, one real solution is when that vertex is right on the x-axis and it's hitting it just in the one spot. All right, last one, part C. Any guesses on how many solutions this one will have? I'm going to predict none, but let's see where this goes. So we have standard form equal to 0. Here's our A, B, and C. So let's plug that into our discriminant formula. B squared, so parentheses, negative 4 squared, minus 4 times our A is 1, and our C is 5. When we calculate that out, we get a negative 4. So if your b squared minus 4ac is less than 0, if it's negative, there are no real solutions. What does a graph of a parabola look like that has no real solutions? That just means your parabola does not cross the x-axis at all. Okay, 2 more. Use the discriminant to find the number of roots of each equation. So roots, that was one of our vocab words. If you're asked to find a root, that is a solution to a quadratic equation. So we're doing all the same math. The fact that some of these vocab words change a little bit doesn't change the math that we're doing. All right, x squared minus 10x plus 25. We have standard form equal to 0. Here's your a, b, and c. So we're going to do b squared minus 4ac. Here's our b squared minus 4 times a times c. I'm just plugging in the numbers. We want to see if we get a positive answer, a negative answer, or if we get 0. When we type that in, we got 0 exactly. That means there is one real, it's going to look like one real root. Because they ask for a number of roots, I'm going to use that vocab in my answer. All right, last problem. Identify ABC, A, B, C. To figure out the number of roots, let's use the discriminant. So b squared minus 4. Now this a is a negative 1 times c, which is negative 10. We calculate that, we get a negative 4. If your discriminant is negative, that just means there are no real roots.